Hello, awesome Algebra 1 students, and welcome back. In this review video, we're going to be going over the steps for graphing linear inequalities with two variables. So the steps for graphing linear inequalities with two variables are very similar to the steps for graphing an inequality in one variable. And these steps can differ depending on how you like to think about it with your thought process. But the way that I do it is step one, I always identify border points, and I use the slope and the intercept to do so. Step two, I check 3 points. I check a point on, above, and below those border points to determine which ones are actually solutions. Step three, I shade in the area that actually has the solution in it. And then step four, I decide the type of line based on my check. Is it going to be solid or dashed? Now, steps 3 and 4 can be interchangeable. And there are some people who like to do step 4 after step 1 because they look at the symbol in the inequality and they're able to tell, but these are basically the 4 steps that I'll be going through. So we're going to look at 2 examples from a worksheet practice and then a couple of examples from IXL. Okay, so in the first example here, we have a linear inequality, and the way that I can tell it's linear is because it's in the forms of slope-intercept form. It has your y by itself, a variable term, and a constant, but it also has an inequality symbol instead of an equal sign. So this right here shows me that my graph is not just going to be a line, it's going to also contain some shaded regions, it might contain a different type of line, etc. Okay, so the first step is border points. So in order to do border points, we're going to start with our slope and y-intercept. So to find the y-intercept, I plug in 0 for x, and that gives me 5 for y. So I know my y-intercept is going to be 0, 5. So I'm going to come right over here and put a point at 0, 5. And then it looks like the slope of this line is 3 over, whoops, what am I doing there? 3 over 1. So that means if my slope is 3 over 1, I'm going up 3 and right 1 from that y-intercept. Now the problem here is that if I try to go up 3 and right 1, I don't have enough coordinate plane to do that. It would go 1, 2, 3, 1, and like my point would be somewhere over here. So remember, if you don't have enough space, you can always reverse the order. I can go down 3 and left 1, and that'll still kind of be in the same spot. So down 3, left 1, down 3, left 1, and then I've run out of room again. My other point would be somewhere down here. Now notice that the next step would normally be to put a line in, but we're not going to do that until step 4. So step 1 is complete. Now, step 2, we're going to check 3 points. We're going to check a point on the line, we're going to check a point above the line and below the line. Now, when it comes to checking, what I always say is the easiest point to check, for x at least, is the value of 0. So in other words, I like to identify the y-intercept right there, and then I check a point above it and a point below it. So the 3 points that I'm going to check are 0, 5, which is the y-intercept, that's on the border point. I'm going to check 0, 6, which is above it, and I'm going to check 0, 4. Now, you don't have to check these points. You could check any point that you wanted, as long as you're checking one that's on, one that's above, and one that's below. So I could have done like -1, 2, -1, 3, and -1, 1. But again, plugging in 0 for x just tends to make my life a little bit easier. Okay, so here we go. In the inequality, I'm going to plug in 6 for y and 0 for x. The nice part about plugging in 0 is that that term is basically eliminated, and I'm left with this inequality statement. 6 is greater than or equal to 5. Is that true or false? That is true, which means this is a solution. We'll come back to that. Go ahead and plug in 0, 5. Again, plugging in 0 will eliminate that middle term. So I'm basically, oops, 0, 5. What am I doing? I'm plugging in 0, 6 again. So I'm basically just, again, comparing it to 5. Is 5 greater than or equal to 5? Well, 5 is not greater than 5, but it is equal to, so that's also true. And yes. And now I'm going to do it with 4. Plug in 0. Is 4 greater than or equal to 5? No, that is false, which means not a solution. Now, step 2 is done. You should always have at least one solution and at least one non-solution, and then the one in the middle is going to depend on the symbol. So it looks like to me that the point above the line was a solution and the point on the line was a solution. So now we're going to shade. So this is the point above the line, right? So now we're going to shade basically everything in the region that contains that point. So everything above these border points gets shaded in, because that's the region where this point is. And then the type of line will depend on this point here. If the point on the line is a solution, it's going to be solid, because solid means set of solutions. And if not, then it's going to be dashed. But it looks like this one is actually solid. So we're going to go ahead here and put in a solid solution line. And there is our first one. So again, going through the steps, we first started with our border points, which this line wasn't actually really great, so I'm going to redo that. We started with our border points, and I'm going to do it in a little bit darker color, right? Then after we found our border points, I'm going to go whoop, just like that. We checked 3 points, above, on, and below. From there, we were able to identify our solutions. So our solutions were above the line and the line was solid. And that's how you graph a linear inequality. All right, we're going to do one more example from this worksheet. We're going to go all the way down here to this one because it's a little bit more challenging. We're going to go to this one right here. Okay, so for this one, same series of steps. We're going to start with our border points. So when I plug in 0 for x, I'm left with 0 for y. So the y-intercept here is 0, 0. And then when I go back here, I have the slope appears to be -2/1, which means I'm going down 2 and right 1. So from here, I'm just going to put in my points, down 2, right 1, down 2, right 1. And you want to find all of your border points. So go back to where you started and reverse the order, up 2, left 1, up 2, left 1. Now, I'm going to check 3 points on, above, and below. And the easiest point to check is when x is 0. So I'm going to check 0, 0 because that's my y-intercept. 0, 1 is above it, and 0, -1 is below it. Okay, going to plug this in. Now, the nice part about plugging in 0 for x is that you're left with just 0. So we have, is 1 less than 0? No, that's false. Okay, now we're going to plug in 0 for x and 0 for y. Is 0 less than 0? Also false. Now we're going to plug in -1 for y and 0 for x. Is -1 less than 0? True. So again, we have at least one true and at least one false, and the middle one will kind of depend. So it looks like here, the only solutions we have are below the line. So that means we're going to shade everything that contains the side of -1. So that would be this region all over here. These are all solutions to the linear inequality, and there are infinitely many, so we want to do our best to shade them in as best as possible. Okay, now, because the solution on the line, or the point on the line was not a solution, we're going to use a dashed line. Now, I don't think, no, my thing doesn't give me the option of doing a dashed line, so I'm going to go in and just do the dashed line as best as I can. So we're showing that, hey, this is the set of border points. So this is where our solutions start. But unlike the first example, these points are not actually solutions. And that's your graph to the second example. So again, start with your set of border points, check 3 points on, above, and below, and then shade in your solutions and determine your type of line. Okay, last but not least, we're going to do a couple of examples using IXL. What's nice about IXL is that it allows you to create the line and the boundary, okay? So it says, plot the points on the boundary line, select the line to switch between solid or dashed, select a read it and shade it. So again, for this one, looks like our y-intercept is at 0, 0. We're going down 4 and right 1. Right now, I have a solid line. So in order to figure out where I'm shading, and whether it's solid or dashed, I'm going to have to check 3 points. So I'm thinking, all right, above, on, and below. So on is probably going to be the point 0, 0. Above would be 0, 1, and below 0, negative 1. Let's go ahead and plug in. So we have 1 less than negative 4 times 0 is 1 less than 0. That is false, so no. Let's see, 0 less than negative 4 times 0 is 0 less than 0. That's also false. And the third one is negative 1 less than negative 4 times 0. Negative 1 less than 0, yes, that's true. So I'm going to use this information. First thing is that I noticed that the point below the line, this one right here, 0, negative 1 was true. So I'm going to shade, and I just click, and boom, the shading happens right there. But I also have to check the type of line. And if you notice, the point on the line is not a solution, which means this line needs to be dashed. So by clicking the line, it'll move from solid to dashed. So this tells me that the point above the line, all of these points above the line are not solutions, on are not solutions, and below are solutions. Click submit, and then it gives us another one that's, again, very similar in style. We'll do this one as our last one again, just to go through it really quickly. So it looks like my y-intercept is 0, 7. My slope is negative 4 over 1. So 1, 2, 3, 4 over 1. Now we're going to check 3 points on, above, and below. Above, on, below. Looks like my y-intercept's at 0, 7. So above that would be 0, 8. And below that would be 0, 6. So when I plug in 0 for x, keep in mind that this just becomes 0. So you're basically left with y greater than or equal to 7. So when I plug in 0, I'm left with, is 8 greater than or equal to 7? Is 7 greater than or equal to 7? And is 6 greater than or equal to 7? 8 is greater than or equal to 7, so yes, that is a solution. 7 is also greater than or equal to 7, yes. 6 is not. So because the point above was a solution and the point on was a solution, that gives me enough information to finish my graph. So first, I'm going to shade in the direction of here 0, 8, which was my solution, so I'm going to shade in that direction. And then since my point on the line was a solution, I wouldn't want to make it dashed. I want to keep it solid. And there you go. Okay, so that wraps up today's video. Again, steps are start with border points. Just graph the points like you normally would if it was any other line. Check 3 points on, above, and below. Easiest point to check is the y-intercept because you plug in 0 for x. Shade in your solutions and determine your type of line. Again, some people like to do these steps in a different order, or they like to do the type of line before they do the check. That's completely up to you. Just make sure that your graphs always have a dashed or a solid line and shading in one region or another. That's it for today's video. Have fun graphing linear inequalities, and I'll see you next time.